After electrolyte injection and high-temperature resting, the battery cell's functional structure is initially formed, but it remains uncharged. Heat and pressurize the battery while charging it for the first time with a small current. During this process, an effective passivation film forms on the contact surface between the electrode materials and the electrolyte activating the lithium battery. This step is called formation. A small amount of gas is produced during the formation. Next, remove excess air from the battery core, seal it and fold the edges to complete the sealing. This step is called degassing. After completing the degassing, the battery cell is fully assembled. Charge, discharge, recharged the battery at a specific rate to measure its true capacity. Then, grade it according to the design standards based on this measured capacity. This step is called capacity testing, and the purpose is to ensure the consistency of quality and performance within the same batch of products. After grading, the PET film on the battery's surface will be removed and it will be placed into a specific blister box. Then, visual inspection is used to screen out cells with defects. After the visual inspection, the battery will be placed at 45 degrees Celsius for high-temperature aging for 3 to 5 days. OCV test will be performed on aging batteries. Identify and record test data through QR code. Stand the battery at room temperature for 2 to 3 days. Then repeat the OCV test and record. From this, the K value of the discharge rate can be obtained. Only batteries with a smaller K value are qualified for self-discharge and can be processed in the next step. After all of these steps, we can get a batch of high-quality battery.